Well, hello and welcome YouTube, Mr. Robinson with yet another brand new exciting video, the last one for this week's series of solving quadratic equations. This is using the quadratic formula. We have solved by factoring, but that's only possible if it's factorable, when you have rational solutions. We solved using square roots, which is most advised when you have an x squared by itself or a quantity squared by itself. And then we had quadratics that were possibly not factorable, and you solve by completing the square. We saw that. Now we're going to be solving using what's called the quadratic formula. And you can thank whoever kind of came up with this by saying, I can get x by itself. Here, I'm going to show you this right now, right here. This has to do with having a quadratic that's possibly not factorable, but having a quadratic and actually getting x by itself. I mentioned in the first video by solving by factoring, it's not really, you can't get x by itself when you have an x squared term and an x term. That's actually not necessarily true. If you use completing the square, it's possible. In fact, I have a proof to do this thing. But let's go ahead and read all this. We're going to use something called quadratic formula. Thanks to completing the square, it is possible to isolate your variable, just like I said, in a quadratic equation with a linear term. And there is a formula for exactly that. This formula is best to use in unfactorable quadratic equations if a is greater than 1 and or if b is an odd number. Remember, if b is an even number, we can solve by completing the square, but you saw, I'm going back to my last slide from before, you saw that when it's odd, it's kind of tough. If a is greater than 1, that means you have to do a lot more with factoring, and if it's not factorable, it makes it even harder there. So quadratic formula has its niche and its place. It's pretty foolproof if you know what you're doing with it. You just got to sub in some things and maybe use a calculator. That's it. All right, so here's what this thing says. If ax squared plus bx plus c equals 0, that means if you have a quadratic in standard form, meaning nothing on the other side equals 0 and everything's written in this order, descending order of degree, quadratic, linear, constant. If ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is called the quadratic formula. It looks like a lot. And teachers will often ask you to memorize this. So would I. It's actually not that hard. First of all, you're going to practice it a lot. Second of all, you can do some different things to learn this thing. And they're called mnemonic devices. Mnemonic devices. A mnemonic device is a way of using something else that helps you make sense of what you're doing here. Oh gosh, I don't know examples to talk about right now. Okay, so like Pemdas, or not even. You say, please excuse my dear Aunt Sally, to know the initials for Pemdas for order of operations, parentheses, exponents, multiplication, division, addition, subtraction. If you're in biology, you might have learned the kingdom, phylum, class, order, family, genus, species by kings play chess on fine green sand. Mnemonic devices are different ways for you to learn something by something that's completely unrelated. For this thing right here, a lot of people use a song. I learned it through my teacher when I took algebra. He taught us with the tune to Jingle Bells, where you sing x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And if you kind of have it like lyrics, it's kind of, when I write it out, I still get that song in my head. It's like learning the alphabet. You'll learn it from its song, There's a nice Stephen Wright joke to that, actually, by the way. A lot of other teachers use Pop Goes the Weasel. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So you do something like that, and it'll kind of help you remember it. Now, you don't have to remember it if you have this video in front of you. It's all about subbing and plugging things in. I'm just letting you know that when it comes to practicing it, those are pretty easy ways. So this looks all really confusing and such, but if you have the formula, if you know the formula, it's all just about substituting things in. I'm only going to do 2 examples in this video. Now, like I said, it's possible to go from here to here, but it involves completing the squares. So you can thank whoever came up with doing this right here. And I'm going to show you a quick version. I did it on this next slide right here. I go from one to the other. I go from here all the way down to the formula right there. You do it by completing the square, and this step's where you do the completing the square part. So if you want to pause and look at that screen, go ahead. There it is. But that's the proof to quadratic formula. It's a lot, so you don't have to do the proof ever. Let's just use the formula and solve equations. All right. So here we go. X squared plus 8x plus 12 equals 0. What you want to do here is you want to identify, first of all, make sure you're in standard form. And we are. We have the quadratic term, then the linear, then the constant, set equal to 0. Good. Next thing is you want to identify what a, b, and c are. Notice when you solve for x here, or whatever variable, in this case we're going to solve for n, but when you solve for your variable, you got to plug in a, b, and c into here. Well, what is my a, b, and c? The a, it's 1. You can't see it unless you write it. A is 1. You got to use that. B is 8, and C is 12. So when it comes to solving for this thing right here, we're just going to substitute these numbers into this formula. I'm going to use parentheses anywhere and everywhere that I possibly can to really nail the coffin. Nail it in. In fact, you know what? If it's okay, because I actually didn't ever make a B negative, if it's all right, it's not going to change the rest of my answer really here, except for this one part. I'm going to make B negative, minus 8x. I'm going to make B negative 8. Sound fair? Okay. So x equals negative, check this out, negative B. I'm using this formula here, negative B. B is negative 8. That's why I wanted to use this. Plus or minus the square root of, it's a bad square root. Let me try that again. Plus or minus the square root of B squared, parentheses are important, minus 4AC, all divided by 2A. A lot of writing and sometimes several steps to go along here. I'm going to simplify it a little more on this one. You'll see what I do. Opposite of negative 8 is positive 8. Maybe you can skip that immediately and go straight to that if you know what you're doing. Make sure you do. Make sure you know that it was a negative 8 to begin with. Not really to begin with, but after you change it. And notice this plus or minus here, guys. You know, when completing the square stuff, plus or minus shows up. It's here as well. Plus or minus shows up. Even in my proof back here. When did I take the square root of both sides? Right here. Plus or minus jumps in. So there it is. Plus or minus. So 8 plus or minus the square root of negative 8 quantity squared is positive 64. Minus 4 times 1 times 12. That's 48. All divided by 2 times 1 is 2. Almost there here. X equals 8 plus or minus the square root of 64 minus 48 is 16. All divided by 2. And the square root of 16 is 4. Okay, so we're pretty much there. But notice we're going to have two different answers there because of the plus or minus. So we're either going to do 8 plus 4, remember square root of 16, 8 plus 4 divided by 2, or 8 minus 4 divided by 2. And it's all divided by 2. It's not just 4 divided by 2. 8 plus 4 is 12, and 12 divided by 2 is 6. Rational solutions, by the way, means this was factorable to begin with. I'm giving you an easier one to start off with. 8 minus 4 is 4, and 4 divided by 2 is 2. So x equals 6 or 2. Those are your two answers there. I'll save it till the next part. All right, but those are your two answers there. That's one for that problem. And again, if it was a minus 8x, that actually was factorable there. All right, last problem here. 4n squared plus 7n equals 3. Now, let's establish something first off. We're not yet in standard form. We need to make sure we're in standard form. This is equal to 0. In order to use quadratic formula, it has to be equal to 0. See, if I just say a equals 4, b equals 7, and c equals 3, you go mess up. You go mess up because c isn't 3. 3 is a false entity right now. I got to subtract this 3 over to the other side to reveal what c really is here. And when you subtract it over, you're going to get a minus 3. So c is going to be negative 3 in this case. So I'm going to get 4n squared plus 7n minus 3 equals 0. So my a is going to be 4, b is 7, and c is negative 3. And it makes all the difference in the world because multiplying a positive by a negative changes from subtraction to addition. It's really going to change everything about your answer, so you can't mess that up. So we're in standard form now. We've identified a, b, and c. Before I start this problem and just plug things in, because this is an alternative that I recommend to some of you guys. I tend to not do it as much, but I do some of this other stuff really fast. Notice in this last problem, I spent a heck of a lot of time working inside this thing, inside the square root. I had to see the opposite of negative 8 is just 8. 2 times 1 is just 2. These guys had to hang out for a long time while I'm doing this part again and again and again, and then taking the square root right here. I had to do that over and over and rewrite a lot of stuff. So true or false, most of the work you do is inside the square root? True. True or false, there's a way to simplify this? True. Let's just work on the inside first. This thing, b squared minus 4ac, and this is important if you're taking an algebra class right here, just, not the square root portion, but I guess it's kind of a part of it. But b squared minus 4ac itself is what's called the, I gotta spell it right, it's called the discriminant. It's called the discriminant. There's a reason why it's called the discriminant, and it has to do with whether the discriminant is positive, negative, or 0. Because the discriminant, b squared minus 4ac, discriminates against certain numbers here. If it's positive, taking the square root of a positive number is sure different from taking the square root of 0 and taking the square root of a negative. So it changes things. Now I think my discriminant here is going to be positive. That's fine, but I'll talk about what happens if it's negative or 0 after I apply the discriminant. I'm going to do the discriminant portion first. All right, I'm going to do, and if you already started subbing things in, you already finished it, that's great. You can stop watching the video here. The discriminant, I'm going to do b squared minus 4ac. Reason I'm doing this here is because, again, this takes the longest to do inside the quadratic formula itself. Why not just do this part first? Just get it out of the way. 49 minus negative 4 times 4 is 16 times negative 3 is negative 48. Minus negative 48, that'll be plus 48. 49 plus 48, which is 97. So all the work I had to do inside the discriminant before with this part here, I just did on its own. Now 97 is not a perfect square, so taking the square root of it means I'm going to get an irrational solution. That's fine. Okay, so 49 plus 40 is 97. So now let's go back to the quadratic formula. I've already done b squared minus 4ac. Let's check it out. Now it's not x anymore. This time it's n. So n equals minus b plus or minus the square root of b squared minus 4ac. It's all done. All divided by 2a. Now I got to do 2 times 4, which is 8 here. So I'm either going to get n equals negative 7 plus the square root of 97 over 8, or n equals negative 7 minus the square root of 97 all over 8. Now you're going to use the calculator for the rest of the way here because it's an irrational solution. Just be careful here, and I don't know, I don't have a calculator thing on right now. Here, maybe I can open the app for you. Why don't I? I think it's important that I do. Make sure that when you use a calculator here, that you make sure your order of operations says that you're actually going to apply the square root, that your square root term and your negative 7 are going to be added or subtracted before you divide by 8. It's very important that you do that. So bear with me here. I'm going to have my graphing calculator screen up right here. And I'm going to do, and here's where there's going to be a mistake. I'm going to do negative 7, that's a negative plus, negative 7 plus the square root of 97 divided by 8. Now this is going to give me a wrong answer right now. You wouldn't know one way or the other here, but this is the wrong answer because I did not divide negative 7 by 8. I only divided the square root of 97 by 8. If you want to get negative 7 divided by 8 as well, you got to make sure that you either compute this part first in the numerator, meaning hit equals once you hit the square root of 97, or you wrap this part around parentheses right here. And a lot of other calculators can group it a lot more easily for me here, but this is going to be my proper first answer, 0.3561. I'm just going to go and write it down on this one. You can't see it right now. I'm going to round it to 0.36, round it up right there. N is about 0.36 for one of my answers. Now let's do negative 7 minus this, and I'm just going to recall. Negative 7 minus square root of 97. 97, square root of 97 is close to square root of 100, which means it's close to 10. That's what we're doing there. I'll divide by 8. That's negative 2.11 if I round up. Negative 2.11. All right, so that's it. So make sure you do your order of operations when you do those problems there. If you look at my 2 answers there, that's what I got. That's my final solution to those 2, which means I couldn't solve this one by factoring, even though I could have done that one there. Now that's all. There's one other thing I'm going to mention here, and that's on the discriminant portion. I got a positive discriminant. Now, when I take the square root of a positive number, I get a real answer. I'm going to get a positive number. Like I said, it's close to 10. Let's say it's square root of 110. All right? Negative 7 plus 10, negative 7 minus 10. You're going to get 2 different answers. When you have a positive discriminant, you're going to get 2 real solutions. What if your discriminant was 0? You take the square root of 0. Well, that's 0. What's negative 7 plus 0? That's negative 7. Negative 7 minus 0 is negative 7. It's not going to change your answer. You're only going to get 1 solution. If your discriminant is 0, you get 1 solution. What if your discriminant's negative? What if this was negative 97? Well, that's a problem because you're going to take the square root of a negative, and square root of a negative, can't do that. That'll be no real solution. You can't take the square root of a negative, so you can see why they call it the discriminant. It discriminates against certain numbers. If the discriminant is positive, 2 solutions. If the discriminant is 0, 1 solution. If the discriminant is negative, 0 real solutions. All right, so that ought to do it for this one, guys. This is Mr. Robinson here. This is the end of this week's series of videos. You have learned to solve quadratic equations by factoring, using square roots and completing the square, kind of the same thing, only square roots is maybe without having to complete the square, and quadratic formula. Good luck practicing that. My next week's videos is going to be on graphing quadratic equations and even solving by graphing within that. But I'm at my 15-minute mark, guys. Take care. Good luck.